And Monday, Janet and I went to an after-school program at Pickett Elementary School and had the kids take surface temperature observations. And we saw that the ground temperature was about 4 degrees Celsius, so it was above freezing. And the snow was coming in, but I said, well, it'll probably start as rain, and then the rain will evaporate as it's falling. They'll cause the air to cool. They'll change over to snow. Now, what's interesting is where I live out in the country, we had about ½ inch of snow stick on the ground. But in the city of Toledo, I don't think any snow stuck, mainly because of, it's warmer in the city. We have urban heat island effect. So good morning. Good evening, everybody, depending on where you are, I suppose. Welcome to our Globe Mission Earth webinar, the second one for the urban heat island effect tonight. And we have a great group of presenters. We have David Padgett from Tennessee State and Jeff Bauman from Shumate Middle School. And I'll share my screen, show you a few things, and we'll see how it goes. And then we'll turn it over. Well, actually, I forgot who's first. I think it's David's first, but I'm not totally sure. If I'm wrong, then you guys can tell me otherwise, right?
Yeah, I can.
Well, I'm going to share my screen. I'll do some talking, David. So you don't have to. Don't panic yet. But here we go. So hopefully my computer seems to be like dying. So we're looking at data and developing research question today. Just wanted to share with you, this is part of Globe Mission Earth, so it's a NASA-funded project. We're in our 3rd year of that project, and our reach map here, actually very proud. This is the people we reach with our project. So we have, of course, University of Toledo, and our schools around us, and Boston University, NASA Langley, Tennessee State, where David is. We have West Ed and UC Berkeley out west, state of New Mexico. We have Palmyra Cove Nature Center, where John Moore, and then all these other people we reach through different parts of the project. All right. Uh-oh, it's not advanced. Okay. All right, so anyway, hang on a second. I wanted to show you a little results from our urban heat island effect campaign in this thing gets in front of my. All right, so I'm not doing well today because the Zoom thing gets in front of the dashboard above the top. So anyway, showing you some data. If you want to look at data, you can go to the visualization system, click on the pizza boxes, atmosphere, surface temperature, choose surface temperature, and submit. And then these are the observations from today. And then you want to look at, well, who submitted data in October. We do go to data counts and kind of get the dates going here. All right, got to move it to October. I'll just do since October 1st. So these are all the schools. We had over 70 schools participate in the urban campaign in October. You can see the concentrations. Ohio, Michigan, East Coast United States, Croatia, the Middle East, and Taiwan. So that was great. And then I also wanted to show you on the main page of the Globe website, if you scroll down, you get to see these nice data from today. Stats, Earth spheres. So you get down to here and you can see, well, aerosols shows first and who's done the most observations. We can switch that to any of the protocols. We'll switch it to surface temperature. And we can see, actually, Nicole just overtook John this evening, I noticed, as the most observations in the last 30 days. You can look at some more schools. Here's Jeff at 49 in the last 30. I'm close behind with the University of Toledo and some of you others who are on this call. So thank you for everybody for taking great observations this October. And some of you, if you're not muted, please mute your line because we can hear you. Someone's watching some news or has a TV on. And Jan, if you can mute them, that would be great too. So the one thing we want to talk about is to promote students doing projects and then presenting them. And of course, you have to have a good research question. So just a few reminders. The Satellites Conference will be at the University of Toledo May 1st this year, school day. And then the GLOBE Science Symposia. I'll talk about these more, the SRSs, the regional ones. Well, I'll zoom in on these after the other guys talk. And the International Virtual Science Symposia. And then there's the annual meeting in Detroit in July. So actually, why don't we switch over to David. And David, could you take it away? Well, you're muted right now. There you go.
Good evening. I'm David Padgett, Associate Professor of Geography at Tennessee State University and Director of the Geographic Information Sciences Lab, located here in Nashville, Tennessee. And so I've been a GLOBE trainer and partner since 2001. And so our primary objective here at Tennessee State is to develop the pre-service teacher GLOBE certification, training, and professional development. And so I am going to share my screen now and then pull up the PowerPoint presentation that I have prepared just moments ago. What is this? Oh, okay. Let's try this again. Okay, can everybody see my screen? Good.
Yeah, I can see it.
Yeah, so
hopefully others can too.
So I'm going to talk about teaching basic satellite science and electromagnetic spectrum facts via the GLOBE atmosphere protocol in general, and really more specifically the GLOBE surface temperature protocol. So I'm just going to give specifically some of the educators out there some ideas about perhaps how to get students to understand what satellite science is. And I've found that through the surface temperature protocol, there are built-in lessons that could be included as we go through the protocols themselves as a spin-off, if you will, along with other spin-offs that we use already, including geographic information systems for data visualization. So first, a lot of the satellites that we work with or that collect data that NASA scientists and GLOBE scientists and subject matter experts utilize are based upon the or sense data based upon the electromagnetic spectrum. And so oftentimes we talk to students about shortwave radiation and wavelengths outside the visible light. And, oh, this satellite is an infrared satellite. And, you know, as you can see by the emoticon down here, a lot of our students might have that look. And I remember when I first learned about the electromagnetic spectrum, I was like, what's that? And then you get this typical graphic here with the electromagnetic spectrum, and it's like, okay, and what am I supposed to do with this? But if you look at the surface temperature protocol, all of these wavelengths are involved, well, not all of them, but many of them are involved at some level in some way, shape, or form. And I'll get into that more specifically later on. A lot of the data that's sensed by our weather and climate satellites that are used by, you know, in GLOBE and NASA scientists are really sensing data that are related to the Earth atmosphere energy balance, which again can be a somewhat abstract topic when we talk to students. So about the fact that, there's this energy that comes in from the sun, and all this stuff happens to it, and we can actually use satellites to detect some of these wavelengths of energy, and that, these wavelengths of energy are different. They have different effects upon us. So, for instance, the incoming solar radiation that comes in from the sun, or that we might call ultraviolet or some abstract term, but that's shortwave radiation. So we have shortwave radiation that comes in from the sun. It's absorbed by the Earth, and then it is released by the Earth in what's called long wave radiation, or thermal radiation, that of course is detected by some of the satellites that we use. And so again, I'm sure everyone has seen this graphic. To some of us, it makes perfect sense, but maybe the students that maybe perhaps aren't exposed to atmospheric science every day, this looks like a bunch of arrows. But again, when we start to utilize these wavelengths in an applied format, when we start to collect surface temperature data, it might make a little bit more sense.
So David, this is, I'm glad you have this figure there. That's one of the biggest things my students coming into my weather and climate class do not understand, is that the Earth has its own energy, the long wave, and the greenhouse gases are absorbing the long wave energy. It's not the sunlight that they're affecting. So that's one of these big misconceptions the students have coming out of high school.
Yeah, yes, I mean, exactly. And so, I mean, they understand ultraviolet radiation and sunscreen and the 30, 50, 20, but what does that really mean, right? And so, so more satellites. So of course, definitely when we start to do our site characterization, we use global positioning systems, and of course, there are even more satellites. And so, I guess I'm going to date myself. Most of our students missed out on the space age. I mean, I guess they can go to see the movie First Man, or they can go see a movie. What's the other movie? Apollo 13, whatever that Tom Hanks movie was, or All the Right Stuff. I think that was another one. Yeah, they can go watch movies about the space age, but I mean, I remember distinctly, and I'm really dating myself now, I remember distinctly watching Neil Armstrong walk on the moon on my father's black and white TV. Yes, black and white television in 1969. That's one of my, but our students have missed out on that. I remember when the shuttle would launch and there would be nothing else on any of the channels on TV. And maybe Challenger changed it. I remember where you were when the Challenger disaster occurred. I was in the student center at Western Kentucky University on my way to class. I'll never forget it. But now there's no more space shuttle program. And so when we start, some of you probably wouldn't be surprised when you mention GPS to students. They have no idea that their satellites have anything to do with that. I mean, I don't know how they think location, maybe they don't even care. They're just trying to get to wherever it is they're going, the local pub or pizza joint or Walmart or wherever. But you ask your students, you'd be surprised at how many of them do not see a connection between satellites and GPS. Maybe they think there's a genie in their phones. I don't know. But but again, the whole idea of something out in space communicating with your phone or your car is really kind of out there for some students, but then we can really incorporate a satellite-based lesson within the surface temperature protocol, as you'll see, so we can avoid having these confused looks on our students' faces. So here is some of the basic equipment that's used in the surface temperature protocol and atmosphere protocol. So of course the GPS receivers, they receive radio waves. So we've got radio waves from the electromagnetic spectrum. And so here is one way that we can show, here's something that we use those radio waves for, and not necessarily the radio. And so we have radio waves that are received by the GPS receivers. And then the infrared thermometers actually detect energy at the infrared wavelength, which of course we talk about infrared wavelengths from a variety of the satellites that we use when we make observations through with our GLOBE or GLOBE scientists and so on and so forth. Again, when you hear infrared, I remember when I first heard infrared, I was like, what's this red? I mean, I don't see anything red here. And so you can't see it. That's the whole point. But until you really understand that, okay, well, I can't see this energy being emitted by the Earth, but this infrared thermometer can sense it. Oh, so maybe the satellite's doing the same thing as this infrared thermometer. Yes, that's what's happening. You can't see what that infrared thermometer sees. So it's like having a little satellite in your hand. Going further, now I use a Garmin GPS 72 because it has a nice big window, nice large font. And as I'm teaching the students about the obviously the surface temperature and ambient temperature comparisons and so on and so forth, what this GPS receiver also does, it displays the satellites that the GPS receiver is communicating with on the screen. And so I know that we can use our cell phones now, and we have these location apps, but all those apps show us is a lat long. But with this GPS receiver, we can look at satellite geometry. And so why is it that we go out during certain times of day and it takes forever to lock in on 4 satellites, and then we can go out on a different time of day, and as soon as we walk out, boom, we've got satellites? Well, if you look on the left-hand side of the GPS receiver, there's 2 circles. The inner circle has satellites that are those box numbers. Those satellites are directly overhead. The other satellites that are darkened are lower on the horizon. And so these radio waves from the GPS receiver can penetrate clouds and the atmosphere, but they can be blocked by buildings. And so that's why we talk about looking at our environment and why sometimes our GPS doesn't work, because there are buildings in the way that can block the signals. And you can clearly see the satellite geometry there. On a day when we immediately get satellites, we should have a lot of satellites overhead. If we go outside and all those satellites are on the horizon, then they can easily be blocked by objects such as even buildings less than about 3 stories tall, perhaps. If a satellite's low on the horizon, they can be blocked. On the right-hand side of the window are bars that are darkened, that represent the number of satellites that are communicating with the GPS receiver. We have to have a minimum of 4 to get a 3-dimensional location. The more satellites the GPS receiver is communicating with, then the higher our accuracy is. And we can actually measure that to some degree. Of course, in this case, the Garmin GPS receiver gives us some idea of our accuracy. I'm using feet. I know that's a violation, but we could switch that to meters. And so the students get an idea of not only how the satellites are communicating with the GPS receiver, but where they are. When we say that these satellites are geosynchronous, or that a satellite is geostationary, oh, it's moving at the same speed as the Earth is rotating. Then we can talk about, well, how fast is the Earth rotating? And so I have a math question where I ask them, what's the circumference of the equator? How many hours are there in a day? 24. How fast is that point at the equator moving? If it goes 24,000 miles in one day, and we can play some math games along with that. So of course, here's so incoming solar radiation, that's at ultraviolet, shortwave radiation that's emitted by the sun. That's what we're exposed to every day. That's what, in some cases, we have to protect ourselves from. If we're not careful, we can get sunburned or have other problems. That's that shortwave radiation. Then, of course, there's visible light, that very narrow portion of the electromagnetic spectrum that is visible to our eyes, that we can see. And so, again, there are at least 4 or 5 different wavelengths, and we could even throw radar wavelengths in there if we want to, if we start to talk about radar satellites at some point during the discussion as we are looking at atmospheric data. So of course, there are numerous satellites that are associated with the GLOBE program. And so again, when we mention that a satellite is geostationary and that it's using various wavelengths of energy, if we can make students understand what those wavelengths mean through hands-on engagement with the instruments that we use during the surface temperature protocol, then they might have a little bit of a better understanding of what these satellites are doing and what they're detecting. The satellite that we've been using the most here lately is the CloudSat, or satellites that are working with us when we are doing the cloud protocol. The GLOBE Cloud Protocol, we go out with the GLOBE charts, and the students are obviously doing the hands-on observation, but of course we now have the GLOBE Observer app, which is a really neat tool. And so of course we are able to go out with the GLOBE Observer app and take observations. I think this was from about a year ago, and so it's a very easy to use application. My students have been able to successfully put it on their phones. I would suggest doing a dry run first because there can be some issues, these students and their data plans, and but once the students learn how to navigate the app, it's a really neat tool. But what's even neater is that after we collect data in the field, then of course, as we know, we can look at what we observed. So on this image, here are the ground observations taken by the students, and then here's a geosatellite observation taken around the same time, and so we can compare what we saw. So in this case, we thought that we saw approximately a 50 to 90% coverage, and cumulus or low clouds. Satellite saw just about the same thing. So cumulus clouds looks like there, and well, the cloud cover percentage wasn't quite the same, but it just shows the students that perhaps there's more than one viewpoint or viewshed or viewpoint on seeing things. And of course, go to another one. Now here's one that was interesting. We got low clouds, cumulonimbus and cumulus, and the satellite didn't appear to have anything, and it has the image there. So who knows? I mean, there are a lot we could have that could prompt a lot of discussion about, well, why is there that discrepancy, even though the time was almost spot on. The longitude wasn't exactly the same, so maybe they were a little bit farther east than where we happen to be, so maybe that was the issue. And we can kind of talk about how we have isolated areas of weather, and that just because it's sunny here a few miles away, it might be cloudy or vice versa. And the satellite, obviously, it's not like that movie. I think there's a movie with Will Smith. It was, I don't remember, but there was a satellites were literally following him around. And I try to tell the students, no, it's not, who knows, it could be. Well, I mean, but hopefully not. And so here's one more where we, this was interesting. So the students thought that they saw alto stratus clouds, and the satellite saw lower clouds. But we did get the cloud cover just about the same as a satellite. And so this is like really neat, especially for students, to see that, here's what we saw, and here's a satellite that's way, way, way above the Earth. And so we can perhaps explain, well, how come this satellite knows what the temperature is? Well, that's that infrared radiation that they're able to detect, that we detected using the infrared handheld thermometers. And so we can actually sense the same data that we might be sensing either with the alcohol thermometer or maybe with our weather station on the ground. And so I guess we're probably not going to take, are we taking questions now or?
Yeah, actually, it's probably a good idea. A few minutes of questions before we turn it over to Jeff. So do you have any questions from anybody?
We use a 7-second rule.
Yeah, that's right.
This is Sheila Stevenson. No question, just wanted to commend you on a great job with the youth. I mean, that was very awesome from what I could tell, your presentation and what have you. So.
Well, thank you. I appreciate that.
Yeah, I would second. I was going to say the same. Thank you, Sheila, for bringing this up. I feel the same. So kudos to you for really doing all this very important work with the students. It's just really benefiting them tremendously. And I believe if anyone have questions, you so kindly provided your email at the beginning. So I think it would be okay to send you a question after the presentation.
Yes, I do have my email address and contact information here in case.
Sure. Thank you, and good luck with everything you're doing. It's very important for the kids and for the whole community.
Yes, this Globe Mission Earth project has been really a great opportunity, especially for the historically Black college university, for us to reach out to communities that are underserved in science, technology, engineering, and math. And so, you know, my students go out and work with 9th graders and younger students. And now we're even bringing in an elementary GLOBE component. So we're getting, I guess, K through 4 and then 9 through 16 vertical integration model developed here. So I'd like to thank the whole Globe Mission Earth team that is very supportive of everything that we do here at Tennessee State.
So Joanne asked a question about, are the surface data supposed to be taken around solar noon, or are they wanting satellite flyover data? And I think that's probably a question that I can answer. For the Urban Heat Island campaign, put in data anytime you get it. So not necessarily around solar noon. If it works better for you to do earlier or later, that's fine. The satellite flyover is good too, and that's one of the things you know, Dave was pointing out, how the students are observing the same wavelengths that the satellite are observing. And I don't know if the students understand that. The one thing that's nice with the student data, there isn't an atmosphere between them and the ground. The satellite has this atmosphere between the satellite and the ground. So the student data is, I would say, more accurate than the satellite for its location. So anyway, that's something, is don't worry about the satellite overfly, but that is something that some of my students have done, is the comparison. Are there any other questions?
One other question. Will the presentations be made available to us later on if we want to review them again, or share them with our administrators to kind of get them to buy in to this for our research program, since I'm new at getting started at this?
So Janet wrote yes on YouTube in the chat box.
Yeah, there is another question from Sarah. And she asked, do the students log the data themselves into the GLOBE websites? Yeah, well, not the high school students. Yeah, my students, as part of their training, are required to do the data entry. And so, yes, and it's very important that they learn to do that. And what we're doing now is we actually have pre-service teachers that are doing elementary GLOBE during their student teaching, with the support of several of my colleagues from the College of Education. And so, you know, that will get them introduced. I was going to say indoctrinated, but I'll say it'll get them introduced to GLOBE even before they graduate. And so we'll have support for them to go out and hopefully to some of the local schools, and then we'll be able to build upon what we're doing here at even more schools.
So David, could you stop sharing your screen?
Okay.
And I'll share mine for just a second before we go on to Jeff. Well, let's see. I tried to move my stuff around. Well, thank you, David, by the way. That was really good. I always enjoy listening to you talk about the science. It's wonderful. So I just wanted to share, we looked at the surface temperature data like for today. One thing students can easily do, if you go over here on the toolbar, and I think I'm sharing my screen, if you click on the three dots, choose base map. See the different ones were on street map. You can do satellite, you can do hybrid. But if you scroll down here, these are all the satellite programs that are associated with GLOBE. And the data is input pretty much every day. Look at that. See that? I just clicked on it, it came up. So this is the satellite data from MODIS of surface temperature. We could zoom in here on the Middle East compared to what the students took today. I mean, that's pretty sweet, huh? Okay, you can do the same with the SMAP data, well, the aerosols, all these other things. And there's a research project right there. How does the satellite data compare to the student data? And usually for surface temperature, the satellite data should be cooler because of the atmosphere. All right, just wanted to share that. All right, Jeff, are you all set?
Can you hear me?
There he is.
All right. Hi, everyone. I'm Jeff Bauman. Before I get going, I just want to kind of piggyback on what David was talking about. I teach a science methods course here at the University of Michigan Dearborn, and I also teach a science capstone here. And one of my requirements for my courses is my students must get GLOBE certified. So they have to complete the e-training. And well, I guess you're recording this, so I'm just going to let it out. I don't care. But one of the requirements, they have to complete 7 modules in 485, which is methods, and then they have to complete 7 methods and 7 modules in methods, and then they have to complete another 7 in capstone. And what I did was I swapped out my midterm exam for that training, and it's a win-win all the way around because the students have the GLOBE training for their resumes as they're about to head out, and just being honest here, it's so much easier to grade for me. So it's really a beautiful thing because you got to pass with an 80% at least to get your cert. So it's worked really well, and I think it's cool that you're doing it. I'm sure Dr. C, you're doing that stuff as well. And kids need GLOBE teachers, and that's just it, from what I've seen. That's what they need. They love doing GLOBE. And before I start sharing tonight, I have 2 students that are on the webinar with us. We have Nick and we have Addie, both Shumate citizen scientists that are enrolled in my GLOBE advisory class I'm going to talk about in just a second with you. So it's great to see Shumate students here tonight with us. So I'm going to try this share thing. I should be good to go. I'm going to share. There we go. Can everybody see that? All right, cool. So slideshow. I'm going to start from the beginning. I'm Jeff Bauman. I teach 6th and 8th grade science at Shumate Middle School in the Gibraltar School District. I'm also an adjunct educational technology and science education professor at the University of Michigan Dearborn. I'm still here. I haven't made it home just yet. And I've been a GLOBE teacher for about 4 years now. When training happened, I was working with Andy Henry from Wayne Risa, David Bidlowski, and Dr. C. So I've been trained by the best. And we're doing some really cool things at Shumate with citizen science. My hashtag is getting science done. It's obnoxious. I put it all over everything, but that's what I believe, and that's what we do. We learn science by doing science. And if you check us out on the next slide on Shumate Science, if you haven't liked it already, I don't know what you're waiting for. You should do that now. You like that, huh? But with we always showcase our work, and we have a pretty hardcore hands-on approach at Shumate Middle School, and I think we're doing good things for our students. My contact information is here as well. Like I said, Facebook Shumate Science. You can also find me on Twitter. if you'd like. But that's the group of educators I work with, and they're all rock stars, and I love working with them. So moving on, this is Shumate Middle School and the Carlson High School campus. This is an image that we captured with the Aaron project that I'm doing with, like I said, David Bedlowski, Andy Henry, Jeff Bland from NASA as well. We send kites up with Aerocats. This picture was taken with a high-def camera of our campus about 400 feet up, and so we can see quite a bit. The students love flying the kites for the Aaron project and that whole remote sensing thing. We're going to get more into it, but it's so cool being part of that. I know you're doing that in Toledo as well, if I'm not mistaken. So that's I'm sure you're loving it as well. So that's our campus, and you can see the wetlands around Shumate and Carlson. Off to the left there, we have Lake Erie, and I'm going to go one higher. And so this is straight up from Shumate. You can see the wetlands just to the north, the canals. And then if we were to go a little higher up, the red circle is where the Shumate Carlson campus is. We're right next to Lake Erie, and I got to be flat out honest with you, it is a science teacher's playground, having that much water, wetland, awesome terrain around us to study, take samples, get science done with students, and it's a really cool thing. Trenton Channel, Detroit River's right there. Lake Erie to the right, Groseal where I live. I've taken some Aaron video from the Groseal Airport down there. I got some really cool stuff. So a lot of learning science by doing science. And I guess that kind of leads into my new baby this year, which in the past when I did GLOBE at Shumate, my students did GLOBE every hour. And so I would use the train the trainer method. I would train 2 Rockstar students every hour, and then they would take students outside, take the measurements, and come back in, 10, 15 minutes later. The students all uploaded their data to the GLOBE website, so we trained them, and they would upload their own data. Occasionally, I would stop in, check on the data, make sure it was all good, and for the most part, it was legit. It was all good stuff. I did quality control with them, and we made sure our data was good. The problem moving forward this year is we started a new science curriculum, and we are bumper to bumper packed with science, and I cannot fit GLOBE in like I used to. So I begged my boss, Mr. Cassie, who is an awesome administrator. He loves GLOBE, has my back 100%. And he said, you know what, how about you move GLOBE to advisory time? So now I do GLOBE with my students every day for 25 minutes during our advisory period. Now, in the past, every kid would get the GLOBE experience. I would send them out. Some were loving it, hands-on. Some just, fine, if I got to go outside, whatever, I'll go do it. Bauman's making me. It's on the Sign Up Genius, so I got to go out. And I wish that I could reach all of them, but with what we have to do, I can't. So with GLOBE Advisory this year, to get in my advisory, students had to apply. So they had to write an essay. Why is citizen science important? What would you like to study? And then I went through all the applications, and I selected 25 students. I have 8 groups of 3 and 1 student who is so busy all day long that she is actually doing her own GLOBE project outside of school hours that I'm just sponsoring. So, but the advisory is a brand new thing, and that's kind of helping me organize all of the research. Now, 2 years ago, we did one IBSS project. We were so proud of it. It was like groundbreaking. It was awesome just to be part of it. Last year, we had 3 projects that we did for IBSS and the SRS, and I said, you know what? I want more. I want more people to be able to do this. So now one of the requirements for GLOBE Advisory is that with your study, you have to do an IBSS project. So we're going to have 9 projects from Shumate Middle School that we're going to submit this year. And for a middle school, that's a lot. High school students, man, I was watching them at the SRS, and they got it down. Diana John students, they were, the students I saw from Toledo was outstanding. And so, with middle school, it's a challenge because content knowledge-wise, they're not quite there yet, but we're advancing them. We're getting them there, and it's a good push. So this year, we're going to try to get more students involved. And here are a couple pictures of our students getting science done. Our precipitation team, Haley on the left, she's measuring water integrated hydrology and Horse Island in Gibraltar, right next to Lake Erie. And then our GLOBE advisory is hosted through Google Classroom. This is something new that I'm trying. Google Classroom is something that almost every educator, every teacher should be using. I've never used this as kind of like a share out information hub, you know, just kind of like a wealth of knowledge LMS type thing. And so this was something brand new that I brought all of my students into the GLOBE advisory classroom, much like my Canvas classroom at U of M Dearborn or Gradecraft or Blackboard or, you know, various different LMS systems that you can use. So we set this up, and the students all have, they can post, they can share things. And then the beauty of it is we have all 25 students enrolled. I asked some of my friends to come along, our all-stars, and you'll see Dr. C is on the list here. And so we have some of my friends from GLOBE and Ulysses and Wayne Risa, and I have students, college students that are jumping in, helping out. And so basically, these individuals, I can't begin to tell you how much I thank them. You know, they're coming in, they're mentoring, they're giving suggestions to my students. Some of them are even assigning my students homework. I love that. That is so cool. Dorian Janey gives my students homework, and I'm like, you go. I love it. You have my blessing. Rock on. And David Bilowski does the same thing. So what we have is occasionally our mentors will comment, and the students will comment back, and they talk, and we're going to start sharing ideas coming up here once we start doing the research paper. Right now we're in data mode. We're collecting a lot of data. The kids are so excited to be going outside. That's going to start slowing down here a little bit because it's going to get a little cold. But we're going to be going outside at least 3 times a week, working on research, probably 2 days. So this is how my students are involved. We have mentors coming in. And then we also have, under classwork, we have spots where I set up folders where all the students' work is housed, so we can go in and we can look at each other's work, and you know, everybody has access to it to kind of see what other groups are doing, to kind of share ideas and maybe improve their research. So Google Classroom has worked really, really well as an organizational tool right now for what we're doing. We've been doing it for about 2 months, and I'm loving it thus far. And then the question, I think, I'm sorry, I jumped ahead. My teams are measuring surface temp. We've got 3 different spots that we're measuring. Dorian Janey has some students working on Mission Mosquito. We're working, one group's doing plains and contrails with Marilei Colon-Robos from NASA Langley. She's a rock star, loves helping out. We have students taking water measurements, pH, dissolved oxygen. Some are measuring salinity. We have students measuring precipitation around the campus. I think we have 3 or 4 rain gauges up right now. SMAP is, we were talking satellites earlier. My big thing is working with SMAP. That was when I got my training years ago, that was the big protocol we were working on, and working with Brian Campbell and his team. I love doing SMAP measurements. We like digging holes at Shumate, and we're also in a high flood zone, so it's good to know how much water's in the ground. And then ISAT-2 is the new one that we're measuring tree heights around campus. And then we're doing a little hydrology on Horse Island. So those are the big ones that we're working on right now. And when it came to working on our questions, when we started getting organized, we got organized by group, members, and then the STEM professional that was going to mentor or sponsor each group. And then what we kind of did is we started working on our driving questions. What are we trying to do here? What are we trying to accomplish? What are we looking for? And so moving forward, we're going to kind of refine this a little bit more. But I used a Google spreadsheet like this, and all my students had access to it. And we just started pouring it out on this spreadsheet. And, you know, we got our ideas down, and then we went outside, we started measuring, and now we're going to start cleaning things up a little bit. We're going to keep measuring, but we're going to clean things up, and we're going to pass out the template coming up here. And we're going to start adding content every week to the IVSS template and do our research. So that's kind of like my next step. The questions, junior high students, not the best at it. You know, a lot of guiding, but you know, we'll get there, and we're taking a big step to getting them ready for high school and you know, become better scientists. So that's how I was kind of organizing the whole thing. Here's the group on the right. They're measuring one of the ponds in the front. Moving forward, you know, a couple of the tools that we use, we do Zoom webinars. We have students use my laptop, and we'll call, you know, different people. We'll talk, share ideas. On the right, that's our weather STEM station that we have on the Shumate and Carlson campus. The weather STEM station is being used by a lot of groups. The group on the left here, that is our mission mosquito team. They're actually using our weather STEM station to forecast active mosquito season. And when I wrote the grant for that a couple of years ago, I never in my wildest dreams thought we would be using a weather STEM station to forecast mosquitoes. So we're using our tools to the best of our ability to do as much science as we can. Now, onto the rock stars. Nick is here. This is Nick. He's outside measuring surface temperature at one of our spots. I'm going to tell you something. We can only have one flag up now, because what we found is that the maintenance guys don't like cutting around 4 flags, and if they get mad enough, they actually run the flags over. So we just put one flag out as like an olive branch to like stop running over our flags.
But I think things are the same everywhere, Jeff. University of Toledo, we had instruments out, and the maintenance guys ran them over. It's just the way it is.
It's crazy. So we have one flag now, but I'm going to tell you, Nick goes out every day. He knows what he's doing. His tools are organized in our storage room. He's got a clipboard with all of these surface temp data sheets, and he takes it outside. He does his measurement, and then he records the data. He brings it right back inside, goes right to the computer, and then they enter all of that data into a Google spreadsheet. And I don't want to say it. It was almost too easy with this team. I mean, they're doing fantastic. So that's Nick. And then right here we have Addie, and she's does amazing work as well. Goes outside. I don't have to say anything to her, and she's fantastic at what she does. I think she wanted to take her IRT to Ireland because she went to see some family in Ireland. I'm like, you know, kiddo, you might not want to try bringing IRT, you know, on a plane. That might not. I know.
I've only been stopped at Reagan National once and detained.
Addie,
only once.
Addie, write that down, okay, if you're still listening, all right? So Addie's doing, you know, great stuff as well. She loves it. And then right here we have Chloe, and Chloe's going online to enter her data, you know, and it's really cool that they've taken full ownership for this, and they can manage the whole thing, and it's done right. Right here, this is their data thus far. I pulled this off their Google spreadsheet, so we have 3 different spots and differences, but you know, they're pretty close, and we've had some good conversations about this. I actually use this as an example today during Globe Advisory to show the kids, hey, this is what we're looking for, and you know, we're going to collect a lot of data, and we're going to make stuff like this. And they're like, oh my gosh, that's pretty cool. We're actually going to make our own you know, graph that looks like that. So that's, you know, next step coming up. And then another thing too is that kind of led to a conversation about surface temp versus actual temp, you know, and this was taken from our weather STEM station. We pulled the data from, what was it, September 4th through yesterday. And so, you know, they started looking at, you know, the surface temp data, and I'm going to jump back. And they said, well, what does the, you know, the air temperature look like? So we kind of started doing I call it the data roller coaster. We move and we do this in class, you know. And so it's led to some really cool discussions. And, you know, the cool thing about Globe, and I'm preaching here, is that it's all instantaneous. It's things that you see, and then you can dive into it because it's real world. It's not scripted textbook. It's just like, it's things that you find that aha, and then you attack it with your students, and it's so rich, and the content is so good And when kids get that, man, it's just cool to see that connection, that light bulb turn on. And we've seen a lot of that in the advisory class right now. So, you know, we've done some data talks. And then one of the things, and I'm going to give this guy a quick shout out. I know I'm running out of time, but in the middle, when I organized this, I needed another me. I needed a team manager. So what I did was the young man in the middle, his name is Mohammed. And he was so upset that he didn't apply for the Globe Advisory that he asked me, he said, can I be part of it? And I said, well, you're a little late. And then I had so many projects going at once. I needed, you know, a fiery little guy to like help me organize all this stuff as I'm going from group to group. So I hired him as like team manager. And let me tell you something, he is awesome. He loves it. And he goes group to group and he helps all of our teams conduct research and he makes sure that they're doing it right. So if they don't get the data on the data board, he goes over, he's like, hey, you got to get your data up there, man. You didn't do that right. Go do your job. And it's cool having a little manager with our team. And the kids like even want to do shirts now. I mean, this stuff is becoming like really hardcore. So that's Mohammed. And then, you know, I'm just going to zip through this quick. You know, one of the biggest things when you work with junior high kids is you got to be organized. You can't have stuff everywhere, whether it's hanging pegboard from the back of an old door to hang your tools like you do at home. We have that in the little storage room between my room and Mr. K's room. Just having computers out, you know, soil ovens, just things, you got to be organized, having your instructions posted on a wall. That way, if kids get confused, they can, you know, track the steps and, you know, kind of be, you know, solve the problem, you know, on their own. And then this is my data board on the left. I have a huge dry erase board in my room. I taped it all off of the different things that we measure. And so after kids submit to GLOBE, put their data on a Google spreadsheet, they record their data on that data board and it changes every day. And so we see those numbers change. And, you know, that leads to more discussions and the kids will come in and they'll start looking and, you know, making observations and they'll start talking to each other. It's worked beautifully in the last 2 years. So that's there. And then I've run out of time. Our GLOBE team from the SRS. Any questions for me, anybody? I talked a little longer than I was supposed to, so.
Oh, you did great.
By the way, thank you so much, Dr. C. I appreciate this, and you know, I looked through the list of people here tonight, and it's an honor to talk with all these science rock stars on the list and get to share out what we're doing, and that means a lot to us. So thank you for letting me do this. So.
Oh, you're welcome.
And
questions for Jeff?
Okay, I am going to stop my share, Dr. C.
Mm-hmm.
You got it now? You good?
Awesome work from Sheila, she says. Now she did ask, let's see, Larissa asked, how long does it take to train the students to enter their own data? Especially you do.
To be honest with you, you've got to find somebody to cover your class for probably, you know, 5 times. You take them outside and, you know, you just kind of, you show them and you do all the modeling. It's that gradual release. You do all the modeling, you do it together, and then you do them in critique. So I usually do that about, you know, 5 times. And then what I do is I let those students go outside and try it on their own. And then afterward, we talk about it. And then it's usually about 2 weeks out. And then after that, when they say, Mr. Bauman, we're ready to go, you know, and then I let them start taking students outside. One tool I didn't mention is Sign Up Genius. It's a free website that a lot of people use for sign up for potlucks, parent-teacher conferences, snack for soccer time, right, Dr. C? And, you know, I use that and I set up a Sign Up Genius for the entire school year. And so the leaders then can go to the Sign Up Genius and know which kids are going outside that day. And then Sign Up Genius will also email the students and say, hey, you're going outside tomorrow during second hour. And it's a really cool organizational tool, and it makes things, you know, really easy to manage, if you will. Another thing, one more thing, my God, I said I'm gonna stop talking, I'm still talking. But just to let you know, with Shumate and our campus, when we let students go outside, you know, obviously we say, hey, this is a big deal. When you go out, you're not goofing around. You goof around, you could lose your spot. You won't have this job anymore. We'll replace you. But our campus is also safe, and we have a lot of courtyards on our campus, and students will go take measurements inside courtyards, and I think we have like 4 of them. And you know, they can actually take measurements, you know, next to the building where I can see them, or in a courtyard. And you know, our campus it's pretty safe and secure. So I've never really worried about students going outside, you know, doing that. So
Thank you, Jeff.
you're welcome. Thank you.
Yeah, great job, Jeff. Yeah, you're an inspiration. you're teaching middle school and college. That's pretty impressive.
I coach robotics too. I didn't mention that.
Oh, okay.
I don't sleep, just so you know. I don't sleep.
Which form of robotics do you do?
We are the middle school, the FTC. We've got
Okay.
5 teams that are going into battle on December 1st. So
Great.
it's the crunch time right now. I'm a little stressed, but we'll make it.
Okay. Good job.
All right.
How often do your college students advise or interact with your middle school students? That's a good question.
Whenever they get the chance to, you know. I think Matt's the one on the list. I think he's I have him set up to do some he wants to do ArcGIS with the students. He wants to take their data and log that. Mm-hmm. I said, you know, this is going to be way over their heads, so when you do this, you're going to have to come in and really, you know, work it with them. And he's like an ambulance driver right now. That's his job, and he wants to become an educator.
Awesome.
And he's driven, and he loves science, and he's just like, can I be part of this, you know? And I'm like, sure, you know, let's train you. Let's get you globe crazy like myself, you know? So
that's great.
Yep.
All right, I just want to share a couple of things as we're closing in 9 o'clock here. See if I can find them. Okay, I think this is it. So we have the regional SRSs, Student Research Symposia, and here's our regions for those of you, you know, I know that we have people from different regions on tonight. The calendar is listed here. All right, so funding application, make sure you get your application in by February 1st to get funding to travel to the SRSs. Let's see, the first one is going to be the Midwest in April. That's going to be in Iowa. Let's see, we have California. I know in Georgia, Mr. Harrison was on. Mr. Harris was on, I think. He's in charge of that one. And Peter from Boston, he's the Northeast. He's in charge of that one. And Tracy, I think, was doing the Southwest, but I think it's going to be at New Mexico, a school in New Mexico, which is awesome. So anyway, make sure that you get your funding in, get your kids going before you know, the deadlines. There's all kinds of good materials associated with this, and of course, I can't remember where any of that is. So, well, I'll just say that there's teacher support, there it is, and then there's student resources, and we don't have time to go through all that. The other thing, though, is the International Virtual Symposium here, and Julie has a nice webinar. You can go see that. Reports are accepted actually starting January 1st all the way through April 10th. April 10th is the deadline, and we'll have a judging period, get your feedback, and then they'll draw for stipends to go to the annual meeting. Of course, the annual meeting this year is in Detroit, so we're excited about that. And July 14th and 19th, the kids will have a good time. 3 days at Howell Nature Center, or at least 2.5. So that's the things we're planning. Now, as far as our other webinars, we have one on February 13th. We're going to have Nectaria from West Virginia University and Diana. Hi, Diana. She's going to be talking. And then April 17th, we're going to do the wrap-up of the surface temperature urban heat island campaign. Okay, well, 2 minutes late. Well, thanks everybody for calling in, and it was great. David, Jeff, you guys did a great job. Appreciate all your insights. Enjoy the snow, whoever is getting it tomorrow.